Construction is the process of creating and building infrastructure or a facility. It differs from manufacturing in that manufacturing typically involves mass production of similar items without a designated purchaser, while construction is typically done on location for a known client. Construction as an industry is 6 to 9% of the gross domestic product of developed countries. Construction starts with planning, design, and financing and continues until the project is built and ready for use. Large-scale construction is a feat of human multitasking. A project manager normally manages the job, and a construction manager, design engineer, construction engineer or project architect supervises it. For the successful execution of a project, effective planning is essential. Those involved with the design and execution of the infrastructure in question must consider the zoning requirements, the environmental impact of the job, the successful scheduling, budgeting, construction site safety, availability and transportation of building materials, logistics, inconvenience to the public caused by construction delays and bidding, etc. Etymology. Construction is a general term meaning the art and science to form objects, systems or organizations. It comes from Latin construction and Old French construction. Construction is used as a verb, the act of building, and a noun, how a building was built, the nature of its structure. Types of construction. In general, there are three sectors of construction: buildings, infrastructure and industrial. Building construction is usually further divided into residential and non-residential. Infrastructure is often called heavy, highway, heavy civil or heavy engineering. It includes large public works, dams, bridges, highways, water, wastewater and utility distribution. Industrial includes refineries, process chemical, power generation, mills and manufacturing plants. There are other ways to break the industry into sectors or markets. Engineering News Record is a trade magazine for the construction industry. Each year, ENR compiles and reports on data about the size of design and construction companies. They publish a list of the largest companies in the United States and also a list of the largest global firms. In 2014, ENR compiled the data in 9 market segments. It was divided as transportation, petroleum, buildings, power, industrial, water, manufacturing, sewer, waste, telecom, hazardous waste plus a 10th category for other projects. In their reporting on the top 400, they used data on transportation, sewer, hazardous waste and water to rank firms as heavy contractors. The Standard Industrial Classification and the newer North American Industry Classification System have a classification system for companies that perform or otherwise engage in construction. To recognize the differences of companies in this sector, it is divided into 3 subsectors: building construction, heavy and civil engineering construction, and specialty trade contractors. There are also categories for construction service firms and construction managers. Building construction is the process of adding structure to real property or construction of buildings. The vast majority of building construction jobs are small renovations, such as addition of a room, or renovation of a bathroom. Often, the owner of the property acts as laborer, paymaster, and design team for the entire project. However, all building construction projects include some elements in common: design, financial, estimating and legal considerations. Many projects of varying sizes reach undesirable end results, such as structural collapse, cost overruns, and/or litigation. For this reason, those with experience in the field make detailed plans and maintain careful oversight during the project to ensure a positive outcome. Commercial building construction is procured privately or publicly utilizing various delivery methodologies, including cost estimating, hard bid, negotiated price, traditional management contracting, construction management at risk, design and design-build bridging. Residential construction practices, technologies, and resources must conform to local building authority regulations and codes of practice. Materials readily available in the area generally dictate the construction materials used. Cost of construction on a per square meter basis for houses can vary dramatically based on site conditions, local regulations, economies of scale and the availability of skilled tradespeople. As residential construction can generate a lot of waste, careful planning again is needed here. Residential construction. The most popular method of residential construction in North America is wood-framed construction. Typical construction steps for a single-family or small multi-family house are: develop floor plans and obtain government building approval if necessary. Clear the building site. Pour a foundation with concrete. Build the main load-bearing structure out of thick pieces of wood and possibly metal I-beams for large spans with few supports. C. Framing. Add floor and ceiling joists and install subfloor panels. Cover outer walls and roof in OSB or plywood and a water-resistive barrier. Install roof shingles or other covering for flat roof. Cover the walls with siding, typically vinyl, wood, or brick veneer but possibly stone or other materials. Install windows. Frame interior walls with wooden 2x4s. Add internal plumbing, HVAC, electrical, and natural gas utilities. Building inspector visits if necessary to approve utilities and framing. Install insulation and interior drywall panels and to complete walls and ceilings. Install bathroom fixtures. Sparkle, prime, and paint interior walls and ceilings. Additional tiling on top of cement board for wet areas, such as the bathroom and kitchen backsplash. Install final floor covering, such as floor tile, carpet, or wood flooring. Install major appliances. Unless the original owners are building the house, at this point it is typically sold or rented. New construction techniques and sustainability as efficiency codes have come into effect in recent years. New construction technologies and methods have emerged. University construction management departments are on the cutting edge of the newest methods of construction intended to improve efficiency, performance and reduce construction waste. New techniques of building construction are being researched, made possible by advances in 3D printing technology. In a form of additive building construction, similar to the additive manufacturing techniques for manufactured parts. Building printing is making it possible to flexibly construct small commercial buildings and private habitations in around 20 hours. With built-in plumbing and electrical facilities, in one continuous build, using large 3D printers. Working versions of 3D printing building technology are already printing 2 meters of building material per hour as of January 2013. Update. With the next generation printers capable of 3.5 meters per hour, sufficient to complete a building in a week. Dutch architect Jan-Jaap Ruijsenaars' performative architecture 3D printed building is scheduled to be built in 2014. In the current trend of sustainable construction, the recent movements of new urbanism and new classical architecture promote a sustainable approach towards construction that appreciates and develops smart growth, architectural tradition and classical design. This is in contrast to modernist and short-lived globally uniform architecture, as well as opposing solitary housing estates and suburban sprawl. Both trends started in the 1980s. The construction site may be shut down due to bad weather. Erecting scaffolded tents over the site may reduce the number of lost workdays, increasing productivity. Construction processes. Design team. In the modern industrialized world, construction usually involves the translation of designs into reality. A formal design team may be assembled to plan the physical proceedings, and to integrate those proceedings with the other parts. The design usually consists of drawings and specifications, usually prepared by a design team including surveyors, civil engineers, cost engineers, mechanical engineers, electrical engineers, structural engineers, fire protection engineers, planning consultants, architectural consultants, and archaeological consultants. The design team is most commonly employed by the property owner. Under this system, once the design is completed by the design team, a number of construction companies or construction management companies may then be asked to make a bid for the work, either based directly on the design, or on the basis of drawings and a bill of quantities provided by a quantity surveyor. Following evaluation of bids, the owner typically awards a contract to the most cost-efficient bidder. The modern trend in design is toward integration of previously separated specialties, especially among large firms. In the past, architects, interior designers, engineers, developers, construction managers, and general contractors were more likely to be entirely separate companies, even in the larger firms. Presently, a firm that is nominally an architecture or construction management firm may have experts from all related fields as employees, or to have an associated company that provides each necessary skill. Thus, each such firm may offer itself as one-stop shopping for a construction project from beginning to end. This is designated as a design-build contract, where the contractor is given a performance specification and must undertake the project from design to construction, while adhering to the performance specifications. Several project structures can assist the owner in this integration, including design-build, partnering, and construction management. In general, each of these project structures allows the owner to integrate the services of architects, interior designers, engineers, and constructors throughout design and construction. In response, many companies are growing beyond traditional offerings of design or construction services alone and are placing more emphasis on establishing relationships with other necessary participants through the design-build process. The increasing complexity of construction projects creates the need for design professionals trained in all phases of the project's life cycle and develop an appreciation of the building as an advanced technological system requiring close integration of many subsystems and their individual components, including sustainability. Building engineering is an emerging discipline that attempts to meet this new challenge. Financial advisors. Construction projects can suffer from preventable financial problems. Underbids happen when builders ask for too little money to complete the project. Cash flow problems exist when the present amount of funding cannot cover the current costs for labor and materials, and because they are a matter of having sufficient funds at a specific time, can arise even when the overall total is enough. Fraud is a problem in many fields, but is notoriously prevalent in the construction field. Financial planning for the project is intended to ensure that a solid plan with adequate safeguards and contingency plans are in place before the project is started, and is required to ensure that the plan is properly executed over the life of the project. Mortgage bankers, accountants, and cost engineers are likely participants in creating an overall plan for the financial management of the building construction project. The presence of the mortgage banker is highly likely, even in relatively small projects, since the owner's equity in the property is the most obvious source of funding for a building project. Accountants act to study the expected monetary flow over the life of the project and to monitor the payouts throughout the process. Cost engineers and estimators apply expertise to relate the work and materials involved to a proper valuation. Cost overruns with government projects have occurred when the contractor identified change orders or project changes that increased costs, which are not subject to competition from other firms as they have already been eliminated from consideration after the initial bid. Large projects can involve highly complex financial plans and often start with a conceptual estimate performed by a building estimator. As portions of a project are completed, they may be sold, supplanting one lender or owner for another, while the logistical requirements of having the right trades and materials available for each stage of the building construction project carries forward. In many English-speaking countries, but not the United States, projects typically use quantity surveyors. Legal aspects. A construction project must fit into the legal framework governing the property. These include governmental regulations on the use of property, and obligations that are created in the process of construction. The project must adhere to zoning and building code requirements. Constructing a project that fails to adhere to codes does not benefit the owner. Some legal requirements come from mal-in-che considerations, or the desire to prevent things that are indisputably bad, bridge collapses or explosions. Other legal requirements come from malum prohibitum considerations, or things that are a matter of custom or expectation, such as isolating businesses to a business district and residences to a residential district. An attorney may seek changes or exemptions in the law that governs the land where the building will be built, either by arguing that a rule is inapplicable, or that the custom is no longer needed. A construction project is a complex net of contracts and other legal obligations, each of which all parties must carefully consider. A contract is the exchange of a set of obligations between two or more parties. But it is not so simple a matter as trying to get the other side to agree to as much as possible in exchange for as little as possible. The time element in construction means that a delay costs money, and in cases of bottlenecks, the delay can be extremely expensive. Thus, the contracts must be designed to ensure that each side is capable of performing the obligations set out. Contracts that set out clear expectations and clear paths to accomplishing those expectations are far more likely to result in the project flowing smoothly, whereas poorly drafted contracts lead to confusion and collapse. Legal advisors in the beginning of a construction project seek to identify ambiguities and other potential sources of trouble in the contract structure, and to present options for preventing problems. Throughout the process of the project, they work to avoid and resolve conflicts that arise. In each case, the lawyer facilitates an exchange of obligations that matches the reality of the project. Interaction of expertise, design, finance, and legal aspects overlap and interrelate. The design must be not only structurally sound and appropriate for the use and location, but must also be financially possible to build, and legal to use. The financial structure must accommodate the need for building the design provided, and must pay amounts that are legally owed. The legal structure must integrate the design into the surrounding legal framework, and enforce the financial consequences of the construction process. Procurement. Procurement describes the merging of activities undertaken by the client to obtain a building. There are many different methods of construction procurement. However, the three most common types of procurement are traditional, design, build, and management contracting. There is also a growing number of new forms of procurement that involve relationship contracting, where the emphasis is on a cooperative relationship between the principal and contractor and other stakeholders within a construction project. New forms include partnering, such as public-private partnering, aka private finance initiatives, and alliances such as pure or project alliances, and impure or strategic alliances. The focus on cooperation is to ameliorate the many problems that arise from the often highly competitive and adversarial practices within the construction industry. Traditional. This is the most common method of construction procurement and is well established and recognized. In this arrangement, the architect or engineer acts as the project coordinator. His or her role is to design the works, prepare the specifications and produce construction drawings, administer the contract, tender the works, and manage the works from inception to completion. There are direct contractual links between the architect's client and the main contractor. Any subcontractor has a direct contractual relationship with the main contractor. The procedure continues until the building is ready to occupy. Design-build. This approach has become more common in recent years, and involves the client contracting a single entity to both provide a design and to build that design. In some cases, the design-build package can also include finding the site, arranging funding and applying for all necessary statutory consents. The owner produces a list of requirements for a project, giving an overall view of the project's goals. Several D&B contractors present different ideas about how to accomplish these goals. The owner selects the ideas he or she likes best and hires the appropriate contractor. Often, it is not just one contractor, but a consortium of several contractors working together. Once these have been hired, they begin building the first phase of the project. As they build phase 1, they design phase 2. This is in contrast to a design-bid-build contract, where the project is completely designed by the owner, then bid on, then completed. Kent Hansen pointed out that state departments of transportation usually use design-build contracts as a way of progressing projects when states lack the skills resources. In such departments, design-build contracts are usually employed for very large projects. Management procurement systems. In this arrangement, the client plays an active role in the procurement system by entering into separate contracts with the designer, the construction manager, and individual trade contractors. The client takes on the contractual role, while the construction or project manager provides the active role of managing the separate trade contracts, and ensuring that they complete all work smoothly and effectively together. Management procurement systems are often used to speed up the procurement processes, allow the client greater flexibility and design variation throughout the contract, give the ability to appoint individual work contractors, separate contractual responsibility on each individual throughout the contract, and to provide greater client control.